Okay, so hello everyone. We still have 4 minutes, but I said I guess it's good to take a few questions before we start. So this lecture is already uploaded on Avenue. For those who would like to look into the slides. Why do the test cases for upper triangle not work and some are missing? So, well, the first question is it depends on what you do, Ahmed. I guess this is something that would require some investigation. It works for me, for the TAs, and for your colleagues, as far as I know. So I guess maybe the good thing is you either come to my office hours after the lecture or go to the TA office hours, and then they will help you with this. And some are missing. I believe if you are referring to missing by some functions are not tested during the test cases we give you, that might be correct. You have to add them yourself, right? Remember, you have to add at least one test case for every function or method you write, right? Is last Friday lecture posted yet? I guess I have uploaded it, but still processing. So yes, thanks for reminding me. And because after lecture directly, it will be visible. Abigail, can we put Hilbert methods for? Yeah. So Abigail, again, the general rule is if you want to write Hilbert methods, you are more than free to do this. This is a good programming practice that I kind of encourage you to do if you need. You need to finish implementation the string method. Okay. Yeah, but test cases do run out of the box. I did run them, and I guess in the tutorial video we have done this together. I did run them without implementing any methods, and they were fine. And like, basically all of them will fail, but that's expected, right? But they will be able to run. So I don't think that's the main reason. But well, I guess Ahmed, we can help you if you come to office hours directly after lecture. Okay, so is there any other question? I did this last cases that didn't work now. Okay, so I have noticed that like the number of attendees dropped significantly in the previous lecture and in this lecture. Is this because you guys have midterms going on, or like is there something change, or you feel struggling with Java, or how things are? I know it's towards the end of the semester and you might feel overwhelmed as well. Yeah, okay. Those, I guess the second midterm, like courses with second midterm might be the reason. Okay. Yeah, all the best with all other midterms. Yeah, I completely understand. Unfortunately, someone emailed me about postponing the lab delivery. I will not be able to do this because we have the last lab, which is starting next week, and the lab time is really tight because we almost finished just 1 week before the end of class time. But I encourage some of you to utilize the MSAF policy if you feel you need to postpone one of the labs. Yeah, and all the best with your all other exams. But I guess thanks to the new wallet, you already have all the slides. Why is the exam the day after classes end? I guess our exam is December 16th, which is not directly. I guess there is 10 days or so between the end of class and then the exam. And I'm hoping that maybe the last or the 2 last lectures we will be able also to do some review. December 10th? Oh, they might have changed it. So the last schedule that I looked at was 16th. Okay, thanks everyone. I should relog this. That's interesting. I'm not aware of any instance that they changed the exam time after scheduling it. Okay, let me check then. Well, then that's tight, yeah. Okay, so anyway, so are there any other questions? How is the lab going? Because this week is the deadline for the lab. So if you have questions with regard to the lab, I encourage you to, today we have office hours directly after the lecture. I mean, 5 minutes after, because I just need a 5-minute break, but but simply utilize these things just to make sure you get enough help. Exceptions, the aim is the one that you do in the lab, and we have done one example during the tutorial, and that's all you need to know. So Arjun, this is also during like this is also in the tutorial. You simply just check a case, and if it doesn't conform with your condition, for example, if condition, then you simply just throw an exception with a message. It's as simple as this, right? If you are referring to try catch, then well, not yet. We didn't cover this yet, and you don't need this now. We are more focusing on OOB because that's the more important topic. Starting today, we was focusing. Okay, do we stay here for the office hours? No, Ahmed, we have another link for my office hours, and I guess maybe your colleagues can help you by posting this on the chat. We don't have a second midterm for this class. You guys have enough midterms for other courses. I would say, don't ask for another midterm for this course. Yes, Arjun, that's the tutorial with the lab material. Okay. Okay, so so let's look into today's lecture. Today's lecture is so first of all, it builds on the previous lecture. It's an application of the ADT we discussed, and on the same time, it's a critical lecture for the last lab. What you do in the last lab is we give you a taste of how to deploy a linked list, right? How to traverse a linked list. Most of the examples we will cover in this lecture really you will be implementing in the lab. So hopefully, if you understand the lecture, if you follow my advice by looking into the lecture examples, try to do them yourself before you jump into the lab, hopefully the last lab should be easy enough. The whole topic about data structure is not the focus of 2SH, it's rather the focus of 2SI, but it's important to connect both courses in order not to feel that they are disconnected or in different worlds. So we will cover linked lists because you need this in the lab. Hopefully we finish them this lecture, if not maybe next lecture, and then we will start covering more advanced OOB concepts like inheritance and other topics. Good. So let's see what is a linked list. Simply, a linked list, you have a series of nodes, right? So I want to take one step further back and look into the data structure we all know, which is an array, right? So this is just a simple array. We usually visualize it using this consecutive, you guys don't like the word contiguous, like it's consecutive places in memory. And if you think about it, it's really, you have multiple entries. All of them are on the same are of the same type. For example, if this is array of ents, and once you have the pointer or the reference to the first element, you are able to access all the elements one by one. How to do this? Just simply by the index. Why that's possible? Because they are placed like after each other in the memory. So once you have this, if you increase it by the amount of or by the data size, for example, for int, you increase by 4, as you have been doing in pointers, you jump to the next element, or simply 0, 1, 2, 3 in the high level language, you access different elements. Why? Because they are back to back in memory. If we think about the general case, that might not be generally the case. They don't have to be back to back in the memory. I can have different elements, like this is element 0, element 1, element 2, and they are not back to back in memory. They are separated by other stuff. But now I lost one great advantage of an array, which is once I have the address of this one, I know the address of this one. So how to keep track of this? You simply, we are calling this a node right now. A node is nothing other than like an entry in the array. Entry or node is the same thing. But the additional information you need now is a node doesn't only hold the value. Previously, you only put here 3, 4, 6, 7 end values. Here, in addition to these values, let's say 3, 4, 6, I need one additional piece of information to be able to have my structure. So can someone imagine what is this piece of information that is lost? Address of the next node, address of the next, exactly, because right now we have this information implicit in the array, but by separating them, we don't have the address of this one. So you have to keep the address or the reference in the previous node and do the same thing. So moving from an array to this new data structure, this is exactly what is a linked list. Good. So that's the only difference, the only fundamental difference between an array and a linked list. We previously also discussed some of the advantages and disadvantages of this. We said one of the advantages of an array is that given that they are back to back, can you remember what are some of the advantages of having an array? Well, Rafi and Nicole, keep this for now. We have this later in this lecture or next lecture. Let's think about only a single link, doing pointer arithmetic, easy access to indices. Well, that's correct. And the reason we are able to do this easy access of indices is that, again, entries are back to back, right? So also data locality is very high, which means it can increase the performance of your system. All the array elements are back to back, which means you can easily cache them in your caches and they will make the access time much faster. Good. Well, what are some of the disadvantages? Do you remember? We already discussed this, I guess, a couple of times at least. What are the main advantages of an array? Easy lookup is another advantage. That's correct. You can't increase the size of an array. Fixed size is disadvantage. That's correct, Yan Hao and Arjun. Well, we partially address this using dynamically allocated arrays, but generally need much consecutive memory. Boxy, that's correct. And inserting as well, that's a problem. Good. So inserting is the one we discussed last time. So the first one is you need much consecutive memory. So if I need 1,000 elements, your memory might be fragmented at certain point if you overload your system. So you don't have a consecutive 1,000 free elements to declare your array. You might have 1,000 elements, but they're not consecutive. In this case, you'll not be able to define your array, but you might be able to define a linked list. So that's one disadvantage, that it requires all the memory to be consecutive and free in your memory. And the second one is it's like inserting time takes a lot of time, as we discussed last time. If I'm going to insert here, unless you are inserting at the end, you have to shift everything, which if you have n elements, as Gotong was saying, you need order of n time. So forget about ordering for now, but simply you need, if you have n elements, in worst case, you have to shift all the n, right? The disadvantage of linked list is you don't have the locality that you have in the array because these things are not consecutive, so they might take more time to access. The second thing is you need to keep track of the addresses because you don't have them for free. But the good advantage is you don't require all the memory to be consecutive, and in this case, you might be able to easily declare your linked list even if you don't have enough space for the array. Good. And the other advantage is dynamically allocated because I can add as many elements as I wish, not like the array. And the insertion order, again, is also faster, as we discussed last lecture, and we are going to discuss in this lecture as well. Good. So this is what I wanted to take you from, with like the traditional array and how it maps to a linked list. So given that now we understand this, so I can define linked list as a sequence of nodes. And then these are my nodes. We said that each node might hold a value, but also the node must hold a link. This link can either be a pointer in C terminology or a reference or object in Java terminology that maps to the second element. Good. And to indicate the end of a linked list, I just make the next pointer of the last one as a null. Just write null here. And this concept is the similar one that we have used for strings in C, right? Just indicating that you have reached the end of your linked list. Good. And to be able to access your list easily, you need a pointer to the first element, because otherwise, if you don't have any of the addresses of the nodes, you will not be able to access it, right? So let's say generally, you have what we call a header pointer or reference to the first element. And this is the only thing you need to know. And afterwards, you can access any element using these links that you have, right? Is there any question so far? Okay, good. So we have some terminology here. We say a successor to a node is the node that comes after. So simply, if we have something like, let's say this, let's say we have 3 nodes. Let's say I call this node 1, node 2, node 3, and we have these references or pointers. Then node 3 is the successor of node 2 because it comes after, which means node 2 is pointing to it, while node 1 is the predecessor of node 2 because node 1 is pointing to node 2, right? So successor and predecessor is what is after and what is before in the chain, right? And simply the length of a linked list is the number of nodes you have, right? And as a special case, you might have an empty list where simply you just have a null pointer, right? So this is as if you have your array with no elements at all, right? So if you have a null pointer, that means you have no elements at all. Another special case, if you have a single element, so let's say the header or the head, and you have one element here, can you imagine what might be the next in this case? What should be this reference? If you have a single element in your linked list? Null, exactly, Karina, thank you. So this should be a null pointer because it indicates that no nodes comes afterwards. Good. So like a good discussion that linked list leads to, which is what is the difference between pointers and references? We had this discussion before, but it's good to revisit what we discussed before and apply it to the use case we have. So we said, first of all, pointers, we have spent like 4 lectures and more than this with examples also for pointers in C. Simply pointers hold memory addresses, right? And it allows you to have fine-grained control on the memory. On the other hand, Java doesn't allow you to directly have access to the addresses, but you can still control defining new objects using references. What is a reference? It's just simply declaring an object, right? And I told you at the beginning of Java lectures is you can look into references as if they are pointers, right? Because they point to a certain place in memory. Here again, the difference is you can modify pointers, you can do pointer arithmetic, you have fine-grained control in the memory, but Java, it's like a black box. Or taking the terminology we discussed in the previous lecture, it's an abstract data type. Good. Here we list again some of the operations you can have on references in Java. You can dereference or null them. You can copy them, compare them for equality, but you cannot do more than this, right? There is no pointer arithmetic or reference arithmetic like C. How to create a reference? Again, the 2-step process. The first one is declaring it. So assume, for example, I have a class point, the example we have been looking at, by just saying point1. We call this reference declaration, but you don't store anything in the memory yet. And then afterwards, if you say point1 equal new point, and then you send some initialization, this is the memory allocation. So the key reserved word new is the one that allows you to really create something in the memory. Good. Just another example with another class to do it in the same line. So all of this we already know. And then now let's see how to apply this into linked lists. But let me first look into the chat. Okay, no questions, good. So how to apply this for linked lists? We really need 2 things for the linked list. We need the node value and we need the link, right? Something I can do to leverage classes in Java is to say, given that this thing is exactly the same for all the nodes, I can declare a class that I can call a linked list node or anything, and then I can instantiate objects out of it because they are all similar, right? What do I need for this class? You need 2 things: the value, which here, because we define our list as linked list of integers, then the value is int. And then I need another reference to the next one, which is of the same type of the class, right? So I need a reference that I call next. Next is usually the terminology, but you can call it anything, right? And that's it. And then I need to declare a constructor that initializes the value and the next. So simply you take an int value, and then you take a reference to another object, and then you initialize the value and the next according to this. Good. So this is a very, very simple class. Then once I do this, I can go to the main and start instantiating. So far, we didn't declare any linked list yet, right? That's only separate nodes that they are not connected together, right? And then the simple thing I can do is once I define this class, I can instantiate objects out of it, right? So first of all, I declare a first node, let's visualize it, that has 17, and this is null, right? And afterwards, I can say I declare another node that has the value 23. And what would be the reference that it takes for the next temp, which is this one, which means I'm saying this should point to this, right? And then here I would say another one, 97 is also pointing to temp. So do this, and this should be a 97. And then finally, I would say maybe I call this my list right now, 44 and point here. So just remove this. I have this 44, and this is pointing to this, and I'm calling this my list. Right? So this is how we kind of initialize the chain, right? You create nodes and you make them point to each other. Questions? Yanhao, what does the N do? So this N, as you can see in this example here, Yanhao, is giving you a reference to the node that you should point to. For example, once I declare the first one, which is in fact my tail, it points to null because it's the last one, but anything afterwards should point to the previous one, right? So it gives you the connection. So LL, unlike array, it generates its value from back to front. So that's just an example, right? That's an example. You can really create your linked list using any way you would. Back to front, front to back. It's up to you, as we will see later. But this is just a simple example. Why do you make temp and then change it, Nicole? Because we overwrite it. So simply, I don't need temp afterwards. So what I mean is, you can really define if every node as a separate node, call it N1, N2, N3. But as far as you pass it as an input here, you really don't need temp, right? So let's look into what happens for temp. Initially, this was temp, right? At this line. And then in the second line, I overrode temp by passing it to the other node. So I move temp from here to here, right? And then I do the same thing here. And then finally, temp would be the one. So I use it as a pointer that I move forward with, right? Because I really don't need to keep track of this address as far as I hold the chain, right? The only thing I need at the end is the reference to the first element. Good? Good. So this is, again, a visualization of things. So we have already discussed this. This is another way of doing the creation all in one single line. And let's distill this a bit, right? So if you look into this, let's take it from last here. I'm declaring an object of LL node has the value 3 and null, right? Which is the last node here. Good. Then I am passing this. Remember that LL node constructor takes two values, an object of LL node and a value, right? Here is a string value. So I'm passing all of this, which is also an object of LL node, to another constructor, which is the one that has 2, which means I'm making 2 point to 3. Then finally, I'm passing 2 to 1, so 1 is pointing to 2. And finally, all of this, I'm passing to my numerals, which is the reference to the first element. What I have done here, I was showing you that you can really do all these steps in a single line, right? And this is also an answer to your question, Nicole, why I really overwrite temp, because I don't need it. I can even do all of this in a single line, right? As far as you keep the chain, you are good. Okay. So now, so far, we were able to create a list without even defining a linked list class, right? So we just had an LL node, which is a single element, but by creating the chain, we have a virtual linked list, right? But the problem is nothing connects all these nodes together in reality. What I mean is, for example, assume I want to write a method that operates or traverse the linked list, or as we discussed last time, inserting an element or deleting an element. Well, where should I declare this method? Right now, we don't have a class for the linked list. You only have a class for the node. And it might not make sense to traverse a list inside the single node. So you put it outside in the main, which is not a good choice. So what I can do is use this LL node class to create another class that I call LL list. So this is exactly the same class we had from before. Assume now, this is the class for the node, the one we have been working on. Assume now I'm going to utilize this to create another class that I call SLL, or singly linked list. Why singly? Forget about the name right now, but it's just a linked list. So in the linked list, I said we only need a single thing, right? Which is the head or the pointer or the reference to the first element. And then everything afterwards comes as a chain, right? So I only define the head and that's it. Are we done? Well, because head is of type LL node, then you are good, because LL node will have the chain itself. Maybe the only thing that remains is to define a constructor or declare a constructor and some methods, right? But as far as instance fields are concerned, this is the only thing you want. One question to you, what do we call this using of the class LL node inside the class of called singly linked list? We had a name, a single lecture for this usage. What do we call this? Using composite class or class composition. Thanks, Gotung and Ian, that's correct. Good. So now, assume we want to do some operations. Remember, an object or a class has two things: instance fields, characteristics, attributes, and actions or methods, right? So assume I want to write some methods, for example, traversing a singly linked list. So I am going to write a method that simply, so let's first think about the logic or the algorithm, right? What do I want to do? The only thing I need, as I said, assume this is my linked list, I need the pointer or the reference to the first element, and then keep going through next until you hit, what do you think? Where should I stop, or how can I check that I reached the end of the linked list? Again, you hit the null pointer. Good, that's correct. So here I'm passing a reference of type LL node. I call it here, you can call it anything, this, traverse, index, anything, it doesn't matter. And you say, while here is not a null, I just simply print the value and then increment here, which is in the object terminology, say that here equal here dot next, right? So by saying, for example, initially here was here, which is like here was at the first element. By saying here equal here dot next, I am moving this. What is here dot next is really this one. So I'm moving here to be to the second element. And then I keep traversing here until I check that here is equal null, right? And then that's all, right? This is what you need to traverse a list. Good. One question to you. If I write this method by this way, where am I implementing it? Am I implementing it inside the LL node class? Or am I implementing it inside the singly linked list class SLL? Or am I implementing it in the main, for example? By its in its current form, where this method is implemented? What do you think? In list class, in SLL. Good. So now we have to. So let's see. Is that the case? If I am implementing this in the SLL, do I need to pass the reference to the list? If I'm a member of this SLL class, I might know that you really think it should be implemented inside SLL. That's correct. But what I'm saying is what I'm doing right now, not what should be implemented, right? Clearly, it's not inside SLL because I'm passing a certain point or a certain reference, which I don't need if I was inside the SLL, right? I already have the head. If you go back here, you already have this head, which you can use, right? So clearly you don't do this. So main, yeah, correct, Nicole. So it's inside the main, right? Because here I'm assuming I don't have the LL node class or the SLL class. I'm using it from outside. That's why I'm passing an object to the first element, right? Good. So now this was the first question. The second question is, where should I implement it? Which I believe you answered already. We should implement it inside the SLL class because this is traversing an SLL, which means it should be a method of the singly linked list, correct? So how the traverse working? I just pass a pointer here that's initially at the first element, and then I print the first one, which is like the first value, and then advance here. This is how you advance here. You print the second element, and then you advance here again by saying here equal here dot next, and then finally until you hit the null. If you hit the null, you are done. Good. Is there any question? Okay, good. So this was traversing. So inserting a node. So let's see if I want to insert a node, which is the example we were discussing in the previous lecture. As we said last lecture, there are many ways to insert a node at the beginning or at the last or before a node or after a node or in between two nodes. There are all variations that really you will see all over in interview questions and linked list classes. AK have a question. So when we define a linked list, we define it backward basically, but bringing it in the same normal in order. So as I was answering Yan how AK, you really can declare it anyway, not necessarily backward. Backwards is really the like the natural way, but you can initialize your linked list using whatever you want as far as you keep the chain. But printing it in the normal order, yes, you need to print it in the normal order unless you are asked to print it in reverse order. Sarah, is .next a method defined in Java? Good, that's an excellent question, Sarah. So let's go back here. I say here equal here dot next. First of all, given that it doesn't have any brackets, that means it's for sure not a method, right? Because any method would have brackets. That means it's only a variable. So let's go back to the LL node class. And then what is this next? It's really a member, an instance member of like the pointer or the reference to the second element. Well, am I able to use it? We said in the last lecture, if you don't have any specifier, that means it's accessible across all the project by default, which is public. Is this a good programming practice? No, you should have it as private. But then what you should do is you can use a get next getter method, correct? Yanha, we didn't use SLL yet, right? It's just SLL keeps track of the whole data structure by only keeping track of the head, right? But we will have more examples to use SLL for now. That's a complex structure that making a next point to two different ones. That's no longer a linked list. So let's say now a next only points to a single node. Benjamin, how can we be confident that the memory location of each node will remain allocated? That's a good question, Benjamin. As far as you are accessing that, remember we said Java is handling memory internally through the garbage collector. So as far as you are using them, they are there, right? So this is the contract between you and Java virtual machine is that it will not delete memory because Java virtual machine target is not to annoy you or to get your program running wrong. It's just only eliminating or deallocating the memory if you didn't use it for a long time. Well, Howie, if you know the answer, Howie, that's correct, but this is not our focus. Again, this is not a data structure course, so I don't want to confuse others. If you're an advanced programmer, that's excellent. Yeah. Okay, good. Okay, and okay, so just again to make sure how I answer you correctly, that's also not the case for binary tree. Just to make sure I don't folks give you the impression that that's correct. In a binary tree, you really have two pointers for the left and the right because one pointer cannot really point to two things. So it's again a different thing. But put this aside. You get introduced to this more into SI. Okay. So we have already traversed this. Let's go. I want to insert an element. We said that there are multiple ways to insert things. Let's say we take the easiest one, which is inserting a new first element at the beginning. I already have the LL node class. If I'm implementing, again, there are different ways of writing the method. I can write the method inside the LL node class or inside the SLL class or outside. What is the ultimate good way, which what you're going to do in the lab is really implementing all these methods in the SLL class or the linked list class, because that's where it should be. You're trying to insert an element to a list, so the method should be part of the list. But let's now, we are just for matter of explanation, let's see if I'm writing this in the LL node. What I simply want to insert at front. I want the head to know the front, and I want the value that I want to insert. Once I take these two as an input, I declare a new node. And because I want to declare it at the beginning before the head, I am making its next to be the head. So this might seem confusing, but let's look. Let me see if there is a visualization. Well, no, okay. So simply what you need to do, you are passing this head node, which you assume is the first node, right? And then it has some value, and then it has access to the remaining elements through the next. To insert a new element, you need to first to create the element, right? So which is the first line here. This is line one. Line one is doing is creating a node, taking the value. Let's say the value was 3, generally value. But then I want it to be before the head. So I should make the next to be the head, correct? Which is the second thing. Remember, this is a constructor that initializes the value and the next. Good. And then finally, I want now to return the list, including the new element. So the head can no longer be here. So I want to return the new node index, which is this one, right? Which is the one that is pointing to the first element in the chain. How to use this? In the main, for example, I can write my list equal insert, and my list should be nothing other than an LL node class, by the way, or object. Insert at front, pass my list itself, and then the value. How this works? Remember, my list now is corresponding to the head, right? So passing the head and then taking the value back to the head. Originally, the head was here. Now I need to move the head to be here, right? To be able to shift my list, because I'm inserting at the beginning. So I should update the head as well. So taking the head and updating it back is making you inserting at the beginning. Is there any question? Is that clear? Why do you say object before value? I'm not sure what you mean, Sarah. Can you please clarify what you mean by this? Are there any other questions? Like in the first line, it says object value. First line. Insert at front object. Okay. So that's okay, thanks. So this is just a generic form. Like, for example, I'm just making this generic to say if you have an int linked list, this should be int. If you have a string linked list, should be string. It can be anything. Sorry if this was confusing. Let's call it int, right? So that's simply the type of the value, right? It can be anything. Yeah, but that's a good catch. Thanks, sir. Okay, so we have seen how to implement this in the LL node class. But here, let me ask you, again, by passing this in the current form, like by passing the head node as well as the value itself, and then returning the LL node, where am I implementing this method right now? In its current form, like in this form that we discussed. Where am I implementing it? Am I implementing it in the LL node or SLL or the main? In the main, correct. Because again, I'm passing the LL node and I'm returning the LL node. And I have been using it as if I'm really outside the LL node. If I want to implement this inside the LL node itself, first of all, I don't need to pass the LL node because I have it, it's in my class. And again, I don't need to return anything because I'm updating my current object. This is a difference. So just to make sure you guys get what I mean, this is implemented outside LL node and outside SLL, right? This is an implementation inside the LL node. How this makes a difference? Now I don't need to pass the LL node object because I already have it, and I don't need to return anything because I'm updating myself. How to do it? Simply, I would say declare your object back again, but then you pass the head, which is the one that you have as, like, assuming that you have a head in your LL node, and then you update the head, right? Equal new. So as I said before, it's a convention in linked lists, and this is something independent of Java. It's really for any language, is to keep track of the linked list through keeping track of the head node, right? There is a reference usually to the first element, and this is the key for you to be able to traverse the whole list, right? So yeah, so node and good. So the other thing is, so inserting before the head was the easiest one. Assume I want to insert a node after a given value, right? So how to write the algorithm for this? First of all, if you, after a given value, which means you already have a value, assume now we have end values to search for, but you also need the value of the node to insert, so new value, which is also an int. And then if you're doing this inside SLL or L node, you don't need the head class, right? So you need now two values. The first one is the one that you want to insert after, and then the second one is the one for the node you are going to create. How to write the algorithm? First of all, I need to find the value that I want to insert after, right? So I need to search the linked list, right? Once I find it, now I can create my new object and place it, right? Let me give you one example. Again, let me check if there is any visualization here. Yeah. So assume, for example, I want to insert after a certain element. And let's say this element is find the node we want to insert for, which is 2, right? So I'm passing 2 as the one that I'm inserting after. And this is the new node that I want to insert. What to do? First of all, I need to find the 2 values. I need to traverse from the beginning, check. And then once I hit the 2, I know that I want to insert after. Now it becomes a little bit tricky and you have to be careful, right? How to insert after? You have to do a certain procedure in very clear steps. Otherwise, things will get messy and you lose the chain. So one of the most common mistakes for any operation in linked list is people break the chain, right? How to make sure I don't break the chain? I want this to be after 2. If I just simply update this next of 2 to be here, is that correct? What do you think? If I have done this, is that correct? Why no? Why that's not correct? Need pointer to 3, exactly. If you updated the next of 2 to be this one, which might be the straightforward implementation of inserting after, you lost the address of 3. Remember, this chain or this link is the only address that you have for 3. So if you updated it to be like this, you lost the 3 elements. So you broke your chain, right? So then how to do this, how to insert without breaking the chain? The first step after creating the node is to make the node next equal to this one next, right? By having this, now you already have a clear reference to 3. So it's safe now to update the next of 2 to be like this, right? So first create the node. Second, update its next. Third, update the next of the previous node, right? Questions? Yeah, Karina, Nicole, no, you are all correct. Thanks everyone. Yolanda, yeah, you are all correct. I guess there is some lag, so I should wait for some time before answering myself. Okay, yeah, but you're all correct. So these steps are very important to make sure of. And they are also, we'll come into these steps when we come to the deletion, and you will encounter all these kind of steps when deploying the lab as well, right? Which is you want to make sure you don't break the chain. So how to write the code for this? Let's go back here. Assume that this is the target you are searching for, the value, and then the value of the new node. First of all, I need to search for this target. So I start from the head. As far as it's not null, I do the next. So simply traversing the list and then adding one condition to check. If here dot value dot equals target, what does this mean? This is simply saying if here dot value equal target, then that's the node you want to insert after. Otherwise, you do nothing, right? And then assume I reached the node that I want to insert after. I create my new node. So the first step is to find the target. Second one is to create the new node. Third one is to update its next to be here dot next. And then finally, update the here dot next, which is the target dot next, right? There is one last thing that is remaining, which is what if I keep searching for the target, I didn't find it in my list, which means, for example, I'm searching in this example, we have for 5, for example, or 4 or whatever, it's not here. What will happen is here will reach the null without reaching the target. Then what should I do is either return an exception or print a message that says target not found, and you simply don't insert, right? Any question? Let me check the time, make sure we don't go beyond. Okay, good. Are there any questions? Is that clear? Because if we understand this trick of not breaking the chain, this is exactly the same thing you have to do every time for almost any method in linked list. So if you got questions, please ask. Okay. So yeah, let's have another application that also will use this kind of not breaking the chain trick in. What if I want to delete a node from the single linked list, right? So what should I do? Yeah, I guess there is something on the chat before we move forward. Danny, in the 4, are you asking for all the 3 of those conditions to be satisfied? Good. So in this 4, here is simply saying this is your initial value. 4 only have one condition, which is this one. And here, this is the increment value of the 4. I can simply write it exactly using a while loop as we had in the traverse. In the traverse, we have done this through a while loop. You initialize your here to be head. You say while here is not null. And then at the end of the while loop, you just increment your here, right? Where does the dot equals come from? So, well, this is just trying to be generic code because you want to be independent of the value. But simply, if your value is string, there is a dot equals method. That's why I said forget about it. Simply say here dot value equal target, assuming that our target is int here, right? So simply, most of the inherent types or built-in types in Java have equals method that checks for equality, but this is not our focus. So it's simply saying this, right? Okay, good. So if I want to delete, what can I do? First of all, I need to search for, let me first, which one I want to delete. Let's say the first one. So really there are multiple special cases for delete specially, but let's take them one by one, right? Let me first ignore the first one. And well, yeah, let's take the second case, right? So forget about this one for now, because that's a special case that I'm going to discuss. Assume I want to delete a node that is not the first one, not the last one, right? I want to delete a node that is in between. What should I do? Delete means just dereference it, right? Which means you don't have any pointer or reference to it, because we said in Java, if you don't reference or don't have a reference to a memory, the garbage collector will remove it after some time, right? So if I want to delete it, delete this one, if I just say the one dot next updated to some value, now I lose track of all the other elements afterwards. So what should be the one dot next in order to be able to delete 2? What do you think? 3, but what is 3? So 3 is a value, right? So, and this is a reference, an object of type LL node. 2.next, exactly, Boxy, thanks. So it's simply saying 1.next equal 2.next, which is just doing this. If I have done this, that means I remove the reference for 2. After some time, it's going to be deleted. So you don't have to deallocate or do anything. Just simply updating this reference, you have deleted 2. Now, this is the normal case. This is a conventional case if you have a long linked list. There are 2 special cases you have to take care of, which is what if, let's start with the first one, which is, if there is a question, let me take it first. Don't you have to unlink the 2 to 3 before you update 1 to 3? So, Yanhao, if I update this one, before linking this here, I simply going to lose the pointer to 3, right? And by the way, to dereference a node, you don't need to care about the objects or links that are going out of this node. You only need to care about the ones that are referencing this node, because again, garbage collector rule is a node that doesn't have any reference after some time is going to be deleted, because simply you don't have access to it. Things that are going out of it will be deleted by default, right? Good. So it's just simply saying 1.next equal 2.next. So what I was saying is that now there are 2 special cases for this, as you can imagine, which is deleting the head or deleting the tail. Tail, when I say tail, is the terminology for the last node in the linked list. Why these are special? Because if I'm deleting the head, I need to update my head, right? Because remember, head is your only link that you have for the whole linked list, right? So what you need to do for the head node is simply say head equal. What do you think? What should I write to remove the first element? Head.next, exactly. So saying head equal head.next will move this. So we'll move this pointer from here to here, which means 1 doesn't have any reference. After some time, it's going to be deleted. Yes, and how, as you said, even if you have something out, it's going to be collected, as far as you don't have something in or pointing to this node. Good. So this is just for deleting the head. What about deleting the tail? If I want to delete the tail, what should I do? What do you think? That's an easy one to think about. Assume that 3 is the last one. 2.next equal null. Exactly, Mark. Make the second last equal null. That's correct, Nicole. Thanks. So simply here, if I just say 2.next equal null, I remove this reference, which means, now forget about this one for now, which means 3 after some time going to be collected, right? And then null is indicating my end of the node, right? Good. Is there any question? So I will leave doubly linked list for next lecture, but let me now take, so we are done with the content. So I will take questions if you have ones, and maybe hopefully during the tutorial we'll be able to apply this as well. Har Sahib, so for the current lab, do we add test cases the same way as we did for the C lab? Yes, Har Sahib, you need to add test cases for every method you apply, and you do this inside the test matrix all.java class. Well, this is the class that does all the testing. So yes. Karina, do we ever have to free memory in Java? I assume no, because of the garbage collector. That's correct, Karina. You don't have to, because you don't have fine-grained control in the memory. So yes, you don't need to care about freeing or deallocating, because simply you don't do any dynamic allocation at the first place. So you are correct. Okay, are there any other questions? Salah, can you quickly explain how the head works as a variable? Well, good. So the head is nothing other than a variable of type LL node, and it's just pointing to the first element of your list, right? Why do I need it? Because simply you need, so if you have this chain of nodes, but you don't have any reference to any of them, well, all of them are pointing to each other, but you don't have access to them. So you need one thing on hand to make sure you can access them. And once you access a single node, you are really able to access all the chain. Now, which node you should have access to? Let's say instead of this, I have a pointer to the last element. Does this enable you to access all the elements? Really, no. In a single linked list, no, because this one is not pointing to anything. So you only have access to this one. So let's say another case, which is I have an access or a reference to a one in the middle. Which parts of the linked list I have access to? What do you think? What you guys think? If I have a reference, the last two, yes, or generally anything that comes afterwards, right? That means if I want to access all the nodes in the linked list, the only possible way is to keep track of the first node, right? And this is how I'm talking about single linked list here, right? Which means by having this pointer or reference, you can go through the whole chain until the end, right? This is simply what the head variable is doing. Good. Yeah. Is there any other question? Can you explain how you insert first element again? Good. So let's go back to insert first. So to insert at the beginning of a linked list, what should I do? Is simply let me visualize it. So I have this list here. This is null, and this here, and I want to insert a node. First of all, you need to create the node you want to insert, right? Which is the new node, this one. And I'm calling it LL node. Sorry, I'm calling it new node. And then I'm putting the value here. Good. But this node right now is just isolated. It's nowhere, right? It remains to attach it to the linked list. How to attach it? I simply have the head at the beginning, right? The first node. So I want this to point to this one, right? Which is simply say this new node dot next equal to the head, right? And then one thing remains, which is to move the head to equal to the new node. How to do this? In the way we have done is in the main, you can simply say something like my list, which is the one that is pointing to the head, or simply just say head equal, and then insert at front. You call the function, you pass the value, and then you pass the head. So you are creating the node, updating the head afterwards to move the head from the previous head into the one that is added afterwards. In the lab, what you will be doing is implementing this inside the LL class itself, like the linked list class, which means you already have the head as an input. So you really don't need to pass the head. You only have you have the head as a member variable for your class. So simply you can do this. You can say I'm passing the head and the head equal new node inside the head itself. So this is can be written both in the LL node class or in the single linked list class. Same as TEM. I guess TEM, you are referring to the example where Rookie, the example we were giving at the beginning. TEM is nothing other than just a temporary variable that you create the node in. But head usually is, both are really names. They don't represent anything, but usually head here especially is used as a terminology for the reference to the first element, while TEM can be for anything. Okay, so if you guys have other questions, I'm just going to take 5 minutes break and then go to the My Office Hours link after 5 minutes. If you have questions related to this lecture or previous lectures or simply anything, including the lab, we have office hours from after 5 minutes until 3. So feel free to drop by and ask questions. Thanks everyone. And
excuse me?
Yeah, go ahead, Yanhao.
Can I ask one short question?
Sure.
On the slide 8?
Slide 8. Okay, let me go back. So what is slide 8?
you have the number on the slide, so yeah.
Okay.
So the part I'm not quite understand is you create a new object for the numerals at the beginning, and then you assign this to another object. Like, is that necessary to write the first line like equal to the new LL
I see what you mean. I see what you mean. Simply, you don't necessarily need to do this. What you can do is you can write something like LL numerals equal, then new node, and then all of this.
Yeah, that's the part
That's the
I
more
feel a little
straightforward.
bit
Yeah,
confused.
yeah. Forget about this. So this is another way of writing the head. So I don't want to confuse you, but there are two ways to write the head node. Some refer to the head node as a separate node that doesn't have any value. It only have the next, which is what is like this one is doing. While others are saying head is only a reference to the one that has the value, right? I prefer the second one. So I would say ignore this and write it as LL node numerals equal new LL node and all this thing, right?
Okay.
Yeah, I'm just having this here for matter of completion or inclusivity if in case you had it somewhere, right? But generally what you're going to do in the lab is you would assume your head to be
It's
a
the
node with a
first.
value, which is the first one that has a value. That's correct.
Okay.
Good.
And one more.
Yeah, go ahead.
And
Go ahead,
for
Yana.
one more question, can you go to the next slide, the 9, I guess? I remember you wrote some note, and I don't feel confident about it. I guess that's slide 10. Okay, never mind.
So do you remember what was even the topic?
Not really.
I see. So maybe when you watch the
Yeah.
video, I guess when I went from full screen to the slides, I didn't keep the notes. So if you go when you watch the video and you still have the questions, you can ask about it then. Yeah.
I see. Thank you.
Yeah. Thanks, Yana. Thanks everyone, and I guess if for those who are coming to the office hours, I'll see you in few minutes. Thanks everyone. Bye bye.